Hi, today we're learning about the systems of linear equations and problem solving. So I know I've got this when I can use a system of equations to solve problems. Go ahead and pause and read this page. Okay, so the first example says one number is 4 more than twice the second number. Their total is 25. Find the numbers. Okay, so you're going to write out what it says and use a system of equations to solve it. So one number, so let's say one number is 4 more than twice the other number. Their totals are 25. So we don't know what the first number is, but the second number is 4 more than twice that number. Their totals is 25. So you're going to add those together and find those 25. Now this one actually, you don't have to use a system. You can do it with one. I'll show you how you can use a system to solve this, but you can just add these together. So you get 3x plus 4 equals 25. Subtract 4 from both sides and you get 3x equals 21. Divide both sides by 3 and you get x equals 7. So you know that if the first number is 7, then the second number is 4 more than twice that. So 2 times 7 is 14, plus 4 is 18. So the two numbers are 7 and 18. Now I'm going to show you how to do the same problem using a system of equations. Okay, so one number is 4 more than twice the second number. Okay, so one number is, so x equals, or I'm sorry, y equals, we can do y equals 2x plus 4. Okay, so one number is 4 more than twice the second. Their totals, so x plus y, is 25. Find the numbers. So what you can do is you can use substitution and say, all right, if y equals 2x plus 4, I can substitute that in here, and I would have x plus 2x plus 4 equals 25. And then we end up at the same place that we did to begin with. So you can either set it up as a system or as one equation from the very beginning. All right, the second example says Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each. Non-student tickets cost $1.50 each. If total receipts were $385.50, how many of each ticket were sold? So remember, we're doing systems of equations, right? So what you're going to do when you do this is you're going to write the cost in one equation and the total quantity in the other. Okay, so money in one, total quantity in the other. So students and non-students, we'll just say students and non-students, they sold a total of 311 tickets. Student tickets were 50 cents each. Non-student tickets were $1.50 each. The total receipts, so the total that they made was $350.50. How many of each ticket? So you're going to solve using a system of equations. Okay, how I would like to do this is I like elimination. So look at the two students, or the two S's. Okay, you have 1 and 50 cents. So if I multiply, remember we're getting the least common multiple, okay? So if I multiply the second equation by a -2, that I'll show you what happens. I'm just gonna rewrite the first equation. Now I'm gonna multiply that -2, so I would get -s minus 3n equals -2 times 385.50 is -771. So you see how that did it. Now, right now, that helps me eliminate the s's. So when I work this out, I get -2n equals -460. And then I just divide both sides by the -2, and I get n equals 230. So now I want to plug that in right here to solve for S. So I get S plus N equals 311. So S plus 230 equals 311. If I if I subtract both sides by 230, I get S equals 81. So that tells me that there are 81 student tickets and 230 non-student tickets sold. Terry Watkins can row about 10.6 kilometers in 1 hour downstream and 6.8 kilometers upstream in 1 hour. Find how fast he can row in still water and find the speed of the current. Okay, so we are dealing with a distance, rate, and time problem. So distance equals rate times time. Anytime you're dealing with a distance, rate, and time problem, I want you to set up a table, rate, time, and distance. Okay. If we're going downstream, the boat is going to be sped up by the current, right? If we're going upstream, where is it? If we're going upstream, the current is going to slow the boat down. So if we're going downstream, the current speeds it up. So I'm going to add the speed of the current. If I'm going upstream, the current is going to slow the boat down. So I'm going to subtract the speed of the current. All right, so this says he can row about 10.6 kilometers in 1 hour going downstream and 6.8 kilometers upstream in 1 hour. All right, so we know that rate times time equals distance. So I'm going to multiply this column and this column. Thankfully, it's just by 1, but it would be okay if it wasn't. But 1 times B plus C is just B plus C. And that equals the distance of 10.6. And the second one, 1 times B minus C equals 6.8. So now I'm just going to combine these two together. My C's will cancel out, and I'm going to get 2B equals 17.4. If I divide both sides by 2, I get the speed of the boat is 8.7. Okay, so find how fast he can row in still water. So in still water, because that's just the speed of the boat without the effects of the current, he can row 8.7 kilometers per hour. So to find the speed of the current, we just plug in the B in either equation. So I'm going to plug it in this top one. So I have, if I go 8.7 plus C equals 10.6 and subtract 8.7 from both sides, I get the speed of the current is 1.9. So I would say the current is 1.9 kilometers per hour. All right. So now you're going to do this one. So go ahead and pause the video. Okay, so you can see in the first equation, the two numbers are 4 and 3, and it's the adult ticket is $25 and the child ticket is $18. The first one I used elimination. You don't have to, I just did, and the second one I used substitution. All right, number 2, the Carry Barrel shop manager mixes candy worth $2 per pound and with a trail mix worth $1.50 a pound. How many pounds of each should she use to make 50 pounds of a party mix worth $1.80? Okay, so we're going to put the money in one and the quantity in the other. So she's wanting to mix candy and a trail mix and have 50 pounds of the mixture. Okay, the candy is $2 and the trail mix is $1.50, and she's wanting to make a batch that's $1.80 a pound, and she's going to have 50 pounds. So that means that the total cost of this mixture is going to be $90. Because it's 50 pounds on $1.80 a pound, so $90 for all of that. All right, so what I'm gonna do is I'm gonna use elimination to solve. So I am going to multiply this top equation by a -2. So I get -2c minus 2t equals -100. I'm going to get -0.5t equals -10. So if I divide both sides by -0.5, I would get the trail mix needs to be 20 pounds. So 20 pounds of trail mix. 20 pounds of trail mix. And so that would mean that if C plus T equals 50, then I need 30 pounds of candy. Now, with all that being said, there are multiple ways to solve this problem. This is just one of them. All right, 2B. All right, Eric, a chemistry teaching assistant, needs 10 liters of a 20% saline solution for his 2 p.m. class. Unfortunately, the only mixtures he has on hand are a 5% saline solution and a 25% saline solution. How much of each solution should he mix to produce the 20% solution? All right, so let's do this. Okay, he needs 10 liters. So both together of both types, he needs 10 liters. Now, let's get into the percentages. So he needs, let's see, his total that he wants is a 20% solution. The only mixtures he has on hand are 5% saline solution and a 25% saline solution. So how many should he mix to get that 20% solution? So those are the two equations that we're going to use. Okay, now I think the easiest way to do this is to, first we can multiply the 10 times that 0.2 so we don't get lost there. Okay, so I'm going to say x plus y, sorry, hold on. Okay, I'm going to go x plus y equals 10. And then I'm going to say 0.05 x plus 0.25 y equals 0.2 times 10 would give me 2. Okay, now I don't want all of those decimals there. So I'm going to multiply the whole thing by 100 to get rid of those decimals. So I'm going to end up with keeping the y plus 10, x plus y equals 10. X plus y equals 10 for the first one. And then if I change that second one, I would get 5x plus 25y equals 200. And now you see I'm not dealing with any of those decimals. So I'm going to solve using elimination. You can solve using substitution if you would like. At this point, it's up to you. But I'm going to multiply this top equation by a -5. When I do that, I would get -5x minus 5y equals -50. So I'm going to eliminate the x's and I would get 20y equals 150. If I divide 20 to isolate the y, I'll get y equals 7.5. So then I need to find x. So if x plus y equals 10, x plus 7.5 equals 10. So x would equal 2.5. So that tells me that I need 2.5 liters of x, which was the 5% solution, and I need 7.5 liters of y, which was the 25% solution. I will tell you, most students, the most common mistake that I see is that students forget to do this. They forget to multiply that, they forget to multiply the final percentage by the total weight that they need right here. So that is the most common mistake. All right, so here you go. You do this one. Pause it. Okay, so you can see after working this out, that there's 4 times as many nickels as dimes. So to get the number of dimes, you would multiply the nickels by 4. Okay, and the value of the dimes is 350, more than the value of the nickels. So you have to put the value of the dimes, which is 10 cents, and the value of the nickels, which is 5 cents, plus that $3.50 more. And when you solve this, I use substitution. You get 10 nickels and 40 dimes. All right, next. Okay, so you go ahead and pause, and I'm gonna come back with the answer. Okay, and you see that I have the answer is 4 liters of a 21% solution. So this one was a little bit tricky because it tells you that she has 3 liters already of a 35% solution. She wants to end up with 7 liters. So that means that she needs 4 liters of whatever the other solution is. So we knew that pretty quickly. And then I just substituted with what we knew, so a 35%, so 0.35x, which we know is 3 liters, plus 4 liters of an unknown percent solution equals 1.89. And how I got that, I'm sorry, I did 7 times 0.27 to come up with this number right here. Okay, so when I did that and I worked it out, I got 0.21, which is 21%. All right, so I know I've got this when I can use a system of equations to solve problems. Do you really understand? What system of equations could you use to solve the problem below? A jar contains 50 coins, all of which are either nickels or quarters. If the total value is $8.90, how many of each type of coin is in the jar? So you have to do one equation with the total. So nickels plus quarters equals 50. And then you have to give the value, the monetary value of each. So that is the answer. All right, let me know if you need any help with this lesson.